Welcome to the deep dive. Today we're going to get into the weeds on some pretty high-end specialized sensor tech. We're looking at the NTI E-TLD-100 tape-style liquid detector. And our mission really is to figure out why a piece of tape can be so sophisticated. I mean, the first thing that jumps out is the price, right? We're talking $2,500 for the 100-foot version.
Right.
Though, they do offer a free 15-day trial, which tells you they're pretty confident in it.
Well, they should be. That price tag really signals who this is for. It's for mission-critical environments.
Okay.
It's not just about telling you about a flood. It's about total operational assurance, in places where even a minute of downtime can cost a fortune.
Okay, so let's unpack that. A liquid detection tape. It sounds almost low-tech. What is this sensor actually made of?
So what's interesting is the construction. It uses this self-adhesive sensor tape, and inside it has these tiny copper fiber electrodes. The whole thing is then protected by this durable netted cover, and the core mechanism is all about detecting conductive liquids.
Wait, hold on. Conductive liquids. So does that mean it would just miss something like distilled water or maybe certain types of oils?
That's a really sharp question, and yes, it would, but it's optimized for the most common threats in these big facilities.
Like what?
Leaks from HVAC condensation, plumbing failures, water cooling systems, stuff that's all water-based and therefore conductive.
I see. So it's specialized.
Exactly. And it's built to last. You can stick it right on the floor or tuck it under pipes, and it comes in a weather-resistant enclosure. It's meant to just sit there and work.
And this is where it gets really interesting for me. The sources point to its sensitivity. The minimum puddle it can detect is what? 0.125 inches?
3 millimeters.
3 millimeters in diameter. That's nothing. That's a single drop.
And that's everything, isn't it? That tiny puddle isn't a disaster yet. It's a single drip that could short out a $50,000 server blade in a few hours.
So it's about catching the problem before it's a problem.
It's the earliest possible warning. But, like we were saying, that kind of precision is useless if you can't trust that the sensor is actually working.
Right. The dreaded silent failure.
And that's where its other key feature comes in. It has this continuous tape integrity self-check.
So it's monitoring itself.
Constantly, it's running a diagnostic loop. If that tape gets cut or damaged or even just disconnected anywhere along its length, you get an alert immediately.
So you know your protection is actually active.
For this level of monitoring, knowing your detector is online is just as important as the detection itself.
Okay, so you've got this incredible sensitivity, this self-monitoring, and you're deploying it over, what, up to 100 feet? They have shorter versions, too, I saw. 10, 25, 50 feet.
They do. The 10-foot one is about $550, so it scales down.
And what about the logistics? Powering something that's always checking itself must be a concern.
You'd think so, but it's actually designed for efficiency. It only draws about 60 milliamps at 12 volts. You can power dozens of these from a single unit without, putting a strain on your power budget.
Got it. And I saw in the sourcing that it's TAA compliant. For anyone who doesn't know, why is that detail so important for this kind of hardware?
TAA, the Trade Agreements Act. That's basically a seal of approval for U.S. federal government procurement.
So military high-security installations.
Exactly. It's a guarantee of quality and, maybe more importantly, a secure origin. It really elevates it beyond your standard commercial-grade sensor.
So if we connect this all to the bigger picture?
What you have is this masterclass in balance. You've got this almost microscopic detection capability on one hand.
A 3 millimeter puddle.
And on the other, you have this absolute certainty of operation because of the self-check. It's designed to eliminate failure, both from the leak and from the system itself.
So here's the final thought for you to take away. Given its ability to detect such a tiny leak and its architecture that's constantly monitoring itself, think about those critical environments, not just data centers, but maybe secure communications hubs or financial trading floors. What happens when the market shifts and the reliability of the safety system itself becomes the paramount feature? When the cost of your sensor failing is actually greater than the cost of the leak it's supposed to detect? That's something to mull over until our next deep dive.